All right, we've been spending a lot of time on the law of sines lately. This is a method used to solve oblique triangles. And so the thing is, some triangles aren't set up for law of sines. Some triangles we just don't have enough information to use the law of sines. I'll give you an example of that. Let's say that I had a triangle, an oblique triangle with an angle of 60 degrees here and a side length of 8 and another side length of 12. If I go to use the law of sines here, I'm going to run into a problem right away because I could put the 60 over x, I guess. And then to do the other crisscross, I don't know either other angle. So I would end up with a situation where I have two variables. I also could have it where I have a triangle and I don't know any angles. So maybe I have a 15 and a 20 and a 31. I'm stuck again. I could put a theta in some position, but then when I match it up to the opposite side in a ratio, I'm going to have another angle that I don't know. And so there'd be two variables in that equation too. So if I have either a side angle side triangle or a side 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 triangle, I cannot use the law of sines. I need another method. So law of cosines is the way we use that. So let's go through the law of cosines. We can derive this another time. The derivation is not too hard, but for today we're just going to state the formula and use it. So it's listed with all three sides here, but what I want you to notice is the law of cosines takes the Pythagorean theorem, so c squared equals a squared plus b squared, and it subtracts off this piece here, which is called the defect, because it's essentially Pythag for non-right triangles. That's really what this is. And so that part has to get subtracted off to show that it was not a 90-degree angle. So if you can memorize Pythag, you've got most of the law of cosines. I'm going to generalize this just a little bit because I don't want you to be hung up on which angle you're using. So whichever angle you have, let's call it theta, you're going to take the opposite side and label that your x. So we'll go x squared equals a squared plus b squared minus 2ab cosine theta. That's the better general version to use, and that way you can put any angle in you want, and the x has to be opposite. So x must be opposite theta. And that way we don't have to worry about which angle is which. So let's use this equation as we're going through the law of cosines. Okay, so in exercise 1, angle C is 90. Then the first form of the law of cosines is what famous theorem? I just talked about how that's Pythagorean theorem. But if you put a 90 in for the angle, cosine of 90 is 0. And so when you multiply 0 by 2a and b, that whole term is going to go to 0. And so that's why we get Pythag there when we use a 90-degree angle, which just makes sense because if it's a right triangle, if theta is 90, then we just use Pythag. We don't need anything else. Law of cosines and law of sines are used for oblique triangles. So it makes sense that we don't have the rest of the formula if we have a 90-degree angle. Okay, so using this formula, if we have triangle ABC as shown below, notice I put the x in across from the angle. I want to match that up. So now to set it up, I'm going to solve for x, and I'm going to take my angle and insert it where the theta is. So you might want to take this and try it yourself. Insert the things you know, and come on back in a minute. All right, so when I enter the a and the b, that 8 and 13, they're interchangeable because I'm just going to square them and add them. So it really doesn't matter which one you do first. And then you can put them in any order over here as well. So at that point, I just go straight to my calculator. I type the square root button, since it's x squared. I type the square root button and enter all of this exactly as it appears. There's no need to figure out what 8 squared is and what 13 squared is and what all this is. Just enter it all in. Should get 17.4. And if you didn't, just make a note of it. We'll talk about it. But this is how it should result after using the calculator for that square root. So that's a side angle side version. Remember I said we can't do law of sines if it's an SAS. All right, and so as an SSS exercise, so this is a case where, actually this is the final answer, so we'll come back to that. But so if we're trying to solve for angle D, if we don't know it, we just put a theta there, and we connect it to its opposite side. So this is the whole key to solving an SSS triangle. You must locate the angle you're solving for and draw an arrow across from it. Most of the time, if you're looking to solve the angles in an obtuse triangle, in an SSS triangle, you're going to put your theta across from your biggest side. And that's so that we don't end up with an ambiguous case after the first angle is entered. Because if we put it across from the biggest side, if there is an obtuse angle in the triangle, the law of cosines is going to find it. And the law of cosines is going to find it across from the biggest side. So generally, I'm putting my theta here if I'm not told which angle to solve. This one told me to solve for D, so I put it at D. But if it just said, find all the angles of the triangle, I'm going to put my theta in the biggest angle first. Okay, just keep that in mind for future problems. So I entered my 15 in the x squared spot. That's crucial. The 11 and the 20, they can go in whatever order you want, but you must have the side opposite the angle by itself on the left. Okay. One of the most common mistakes people make on these is they will just combine all of these numbers on the right into a single number. You can't do that. This minus sign separates the 20 squared from the cosine term. That cosine term is all 1. So what I need to do is isolate that first by subtracting these two squares to the left side. So it's going to look like this. So it's 15 squared minus 11 squared minus 20 squared. At that point, now I want to get a single number on the left and a single number on the right so that I can do an inverse cosine. So the left side comes out to negative 296. The right side comes out to negative 440 cosine theta. And from there, it's easy. I can just divide by negative 440 and do an inverse cosine. But we had to get those into single numbers first. So once again, do not combine everything on the right side. Remove the squares first. Calculate all the squares as one number. Calculate the coefficients as another number. Divide them. Do an inverse cosine. And so theta came out to 48 degrees. These negatives, you can write them or not write them. They're going to cancel each other, so it's okay to leave them out. All right, on the next page. So we have SAS and we have SSS triangles. We have a way to solve each of them now. All right, I'm just going to keep this off to the side because that's going to end up being our answer here. This says to enter the side lengths and figure out the length of the measure of the largest angle. So here's what I was talking about on the previous page. If you're not told which angle to solve for, then you have to solve for the largest one first. This one says the largest angle, so I'm going across from the 20, put my theta there. Remember, the largest side is going to be created by the largest angle. So to solve this, I want law of cosines again. You can start this one on your own. Pause it. Come on back when you're done. All right, so I set up my law of cosines. I've got 20 by itself because it's across from theta. I've got my 8 and 14 interchangeably. You might have done 14 and 8, doesn't matter. I'm going to move the squares to the left. Squares need to be together. Coefficients need to be together. Get them down into a single number. So this came out to 140. Coefficients came out to negative 224. So I divide by the negative 224. I do an inverse cosine. This is a negative fraction. When there's a negative fraction, cosine is going to come up with an obtuse answer. So that's what I said before, is that law of cosines will figure out if there's an obtuse angle. Because if it's a negative ratio, it knows that it was obtuse. And that's something that you will definitely see in pre-calculus. I'm, again, not going to get too far into that right now. But if you get a negative ratio and an inverse cosine, you will get an obtuse angle. So this 128.7 is theta. I could then figure out the rest of it. I could do law of sines on either one of these other two angles and get the other two angles. It doesn't ask me to do that, so we are moving on. Exercise B. Using your answer from A, determine the area of this triangle to the nearest square centimeter. Well, once I know that angle, I just want to use the two sides next to it. So 1/2 xy sine theta. Go ahead and enter the parts. Just make sure you can still do it. And so 8 and 14 go in the x and y positions. The angle goes where the theta is. And we end up with 44 centimeters squared. Okay, exercise 5. Now, there's a nice drawing done here for you. Most of the time, context problems are not going to draw the problem for you. So I'm just going to take you through how it was done. We have a plane that is spotted in the sky by this satellite, and it's flying between these 2 points. And the satellite measures the distance to the plane as 35 miles. Quarter of an hour goes by, 15 minutes goes by. And now it's measuring a 58-mile distance, and it knows that it rotated through a 132-degree angle. So we have one line of sight, we have a second line of sight, both coming from the ground. We have an angle of rotation. So if I just connect those lines of sight down to the ground, I clearly have a side angle side triangle here. So that's going to be useful. Now it asks me to determine the average speed of the plane to the nearest mile an hour. And what we know about a relationship between time and speed and distance and all that is that distance is equal to rate times time. So if I can figure out this distance traveled, I know the time traveled, I'll be able to get the rate. Okay, so to figure out this distance, let's use the law of cosine since it's side angle side. And I'll say that d squared is equal to, because it's across from 132, is equal to 58 squared plus 35 squared minus 2 times 58 times 35 times cosine of 132. All right, I enter all that into the calculator because it's a d squared. I can just do a square root, enter all that in under a square root. D comes out to 85.47 miles. All right, and the reason I needed to know that is because if I'm looking for the rate or the average speed, I can now enter that 85.47 into the D position of this equation. I don't know the rate yet, but the time, let's say I want miles per hour. So let's use the hours version of the time. So 0.25, and just dividing both sides by 0.25, the rate comes out to about 342 miles per hour. Now, does that seem reasonable? That's pretty fast, but it is a jet, and jets move pretty fast, so I'm going to say that that's a reasonable answer for that distance traveled, for that rate of travel. So a couple applications of law of cosines. We'll see lots more of these as we go through them in class. But again, just to summarize, law of cosines is used for SAS and SSS non-right triangles.